Hello gentlemen, welcome back. This is the second video on inequalities. We're going to look at two examples. One example is just going to be pretty complicated. It's going to have a bunch of different restrictions on it. We're going to have a system there that we have to solve. And then the last example, the second example, is going to be a word problem that we're going to need to incorporate some of this inequality concepts. Okay, so let's get started. So I want to solve this system equation. Y is greater than x squared minus 4. Y minus 2x is less than or equal to 3. X is greater than or equal to negative 1. And y is greater than or equal to 0. So I have all of these, and what I'm looking for is the intersection of the solution to each one of these. This is a parabola, this one up here. This is a linear equation. This is a vertical line, and I'm going to be shading to the right of that. And this is a horizontal line. I'm going to be shading above the x-axis. So we have to combine the solutions to all of these. The first step I want to do is first let's find the intersection points between the parabola and the line. Now we know how to do that. We basically want to set those two things equal to each other. Remember, I can rewrite this line right here. I can rewrite that as y. This line here is going to be y is equal to 2x plus 3. I set those two equal to each other. What you guys should remember is I bring all the terms to one side, like that. At this point, not factorable, so then if I can't factor it, I want to use the quadratic formula. If I do that, I'm going to get those intersection points right there. Alright, so our intersection points are 3.83 and 10.66. and negative 1.83 and negative 0.66, and we'll use those later on in the problem. Okay, so let's take a look at this. Now, here's my parabola I've drawn. You guys should be able to do all that. Here's my x and y axis. What you should see is that I have a dotted line for my parabola because points on the parabola are not part of the solution. You should see I have a straight line, solid line here, and I have a solid line there. Because those points are on the solution. And I have solid line, vertical line here because those points are on the solution, and I have the x-axis here, which is also on this thing. So now what I'm looking to do is, I have all those lines set up. I want to find out where I satisfy all those different parts of the equations. Okay, so let's start with the parabola. Do I want points inside the parabola, or do I want points outside the parabola? Again, the simplest way is to test a point. So let's test the point 0, 0. If I test for the parabola 0, 0, I'm going to get is 0 greater than negative 4. Well, that's true. So I want to be shading inside the parabola. So let's just make a note, because if I write it in, it'll get all messy. So inside parabola here. Okay, so I want all these points in here. Let's look at the line. Let's test the point for the line. Again, 0, 0 is perfect. All right, so if I plug in 0, 0, I'm going to get is 0 less than or equal to 3. Well, that's true. All right, so I want to be below line, below y minus 2x is equal to 3. I want to be a little below that, either on or below it. So right now, what I'm looking at are these points right here. So if I was just to look at those two, I would be shading right here. Okay, but I also need to take into account that I have to be to the right of this solid line, this black line, this y equals 1, so I have to go this way for the black line, and then I also have to be above here. I have to be above that axis. Okay, so I have to make those two stipulations. So points down here, this part right here, is not going to be in my solution. Either is this little triangle right there, because I have to be to the right of that line. So if I get rid of all that stuff, I should see that's going to be my solution. Okay, and that's a combination of all those restrictions right there. I want to find the vertices of that. So let's do that. I know that I got one here, vertice here, 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 and there. I got one of them already. So I want to find the intersection of the x equals negative 1 in the line right here. That's not a big deal. I get negative 1, 1 there. Obviously, this point right there is negative 1 comma 0, right there. And the other one is when x is equal to 0 on the parabola, which is 2, 0. All right, so those are my vertices of the region that satisfies this solution. Okay. Okay, let's do another example with a word problem. A person plans to invest up to $20,000 in 2 different interest-bearing accounts. Each account contains at least $5,000. Moreover, the amount in one account should be at least twice the amount in the other. Find a graph of the system of inequalities to describe the various amounts that can be deposited in each account. Again, I got to take the words, I got to make some sense of it, and then I'll graph the solution. So let x represent the amount of money in one account and y the amount in the other. And so the first step is, up to $20,000. So I have to have x plus y is less than or equal to 20. Okay, so there's my first sentence. Each account is to contain at least 5,000. So x and y have to be greater than or equal to 5,000. And moreover, the amount in one account should be at least twice the amount in the other. So y is going to be greater than or equal to 2x. Okay? So there are my 4 restrictions based upon the wording in the problem. Okay? Make sure you understand these. Read this carefully. Make sure this all makes sense to you. So now what I want to do is I want to graph all of this. Again, linear, vertical line, horizontal line. Okay, so if I was to graph all those, here's my vertical line, x is equal to 5,000. Here's my horizontal line, y is equal to 5,000. Okay, so just looking at those two, I have to be above this gray line here, or on it, and I have to be to the right of this line there. All right, those two are the simple ones. All right, now what we need to do is, do I need to be above the blue line, below the blue line, and above the red line and below the red line? So that's what we need to look at right now. Okay. So let's do that. Let's look at making that solution. So x plus y is equal to 20,000. So let's look at that. I can say that the point 0, 0 here is on one side, and so is 0, 0 a solution of that? Well, it is, because 0 is less than 20,000. So I want to be below the blue line. So we're going to be below blue. Okay. Let's look at the red line here. Let's look at the point 0, 5,000. Okay. So here we're going to look at the point 0, 5,000. That's right there. Is that a part of my solution or not? Well, if I plug in, I get 5,000 is greater than or equal to 0. So that works. So I want to be above the red line. Okay. So I want to be above the red line, below the blue line. Okay, so right now, if I looked at just that requirement, I would be right here. All right? Okay, now I also have to be to the right of the green line, so that's going to restrict it. Whoops. Okay, so now if I'm above the green line, I mean to the right of the green line, I'm going to now get to this point, and I have to be above the gray line. So it looks like the only part of the solution is going to be that little triangle right there. And it is. Okay? So again, that's where I will have points that satisfy all of the restrictions that were laid out in the word problem. All right, so hopefully that makes some sense to you. Okay? Here's some more practice. There'll be some word problems in there. Make sure that you understand how to utilize these concepts to solve some of these problems. All right? It does take some practice. You have to be really good at graphing things, finding intersection points, things of that nature. So if you're having some difficulty, please let me know. Attend one of the Hangout sessions or email me, and hopefully we can clear up any problems that you have. All right, gentlemen? Have a good day.